So this is 2x1 multiplexer diagram. You can see here, this is 2x1 multiplexer diagram. Okay. And for this, we have 4 PMOS and 4 NMOS in the 2x1 multiplexer. This is 2x1 multiplexer. Okay. And then we also have an inverter. And here what I will do, in the place of inverter, I will put in CMOS terms. So already 4 PMOS, 4 NMOS are there. And here inverter, I am putting 1 PMOS and 1 NMOS. So I will assume this is PMOS 1, this is PMOS 2, PMOS 3 and PMOS 4. Similarly, NMOS 1, NMOS 2, NMOS 3, NMOS 4. And this is PMOS 5 and NMOS 5. Okay. So with this details, I will try to design a 2x1 multiplexer and verify whether the truth table holds good. And the design will be in switch level modeling. Switch level modeling means already we are familiar with a few things. In the theory, we have studied switch level modeling. Already these PPTs are given to you. In the first unit itself, we studied what is switch level modeling. You can see here, this is inverter, switch level modeling inverter. Input is X, output is F. We are defining X comma F. Input is X and output is F. Supply voltage. Supply voltage, VDD, we are giving supply 1, and supply 0, we are giving GND. And PMOS 1, NMOS 1, only 1 PMOS and 1 NMOS are available here. And we are writing the output. You see here, both of them, they contribute to the output F. And for the PMOS, inputs are X and VDD. For the NMOS, inputs are X and ground. So that we are giving for PMOS X comma VDD and for NMOS ground comma X. Okay. So this is the switch level modeling. And PMOS, NMOS, they act as switch. We are using this type of verilog coding to implement the 2x1 multiplexer. Okay, you have seen here, you have to declare what are the inputs, what are the outputs. Okay, you have to declare what are the inputs, what are the outputs. Then what you have to do, supply 1, supply 0, you have to do, give VDD and ground. And then PMOS, NMOS, you have to mention what are the inputs and outputs. Okay. So what are the inputs and outputs you have to mention in the diagram, in the coding. Now, what we will do, with the verilog coding, I will go with verilog coding. If you are working with Xilinx, you can open and try along with me if you have Xilinx in laptop. I will go to a new project. Project name, I am putting switch level modeling 1. Switch level modeling 1. Have some common sense and mute yourself. When I speak out, your common sense is working. I'm noting down numbers. 21, 11, all these people will not get attendance.
Ma'am, it was by mistake, ma'am.
That is the 2-3 times I have observed, then only I'm telling you.
No, ma'am. While joining, it was unmute. I did not mute it. Sorry, ma'am.
Now coming to the new verilog program, I'm taking new verilog program, verilog module. And here we are going to design MUX 2 by 1, MUX 2 by 1. And I have executed this. You can see A, B, S are the inputs, Y is the output. Okay, you see the diagram. Two by one MUX we are implementing. So this is the diagram we are following. A, B, and S are the inputs. And here for output, we are declaring as Y. Y we are taking as output. Okay. And then Y bar, let it be the intermediate output. Here, Y means the final output. Y bar means I am taking this portion as Y bar. Okay. So here 4 PMOS are there. You concentrate and see how I am going to write the coding. 4 PMOS transistors are there. So this is PMOS 1, this is PMOS 2, PMOS 3, PMOS 4. For PMOS 1, inputs are VDD and A. For PMOS 2, inputs are VDD and S bar. Both of them are giving output as A1. Okay, both of them are giving output as A1. You see here PMOS 1, PMOS 2, both are giving outputs A1. And for first PMOS, VDD, A are the inputs. Second PMOS, VDD, S bar are the inputs. Okay, VDD, S bar. These are the inputs. Now I am going to third PMOS. Third PMOS inputs are A1 and B. Fourth PMOS inputs are A1 and S. Output here it is giving, and this I am taking as Y bar. Okay, so PMOS 3 and PMOS 4, output is Y bar. So you see here Y bar are the outputs, PMOS 3, PMOS 4, and A1 is one of the input. B is the input for third PMOS, S is the input for fourth PMOS. Okay, so B is the input, A1 is the input for third PMOS, S and A1 are the inputs for fourth PMOS. Both of them are contributing for Y bar. Okay, so we have written coding for all these 4 PMOS. Now I am going to NMOS circuit. I am going to NMOS circuit. So this I am taking NMOS 1, this I am taking NMOS 2, this is NMOS 3, this is NMOS 4. Now NMOS 1, inputs are A and A2. Capital A and A2, and NMOS 2 inputs are B and A3. Okay, NMOS 1. So A2, A, B and A3. Both of them are giving Y bar as the outputs. You see here, both of these are giving Y bar as the output, and A2, A are the inputs, A3, B are the inputs. Okay, so here A2, A and A3, B. These are the inputs for NMOS 1, NMOS 2. Now I am going with NMOS 3 and 4. See the diagram. This is NMOS 3. This is NMOS 4. Inputs are S bar and ground. Okay. And output is A2. Here, S and ground, output is A3. Okay. So S bar and then ground. A2 is the output. S and ground are the inputs. A3 is the output for NMOS 3 and 4. Okay. We completed 4 PMOSs, 4 NMOSs we have represented using this logic, same as inverter, how we have done basic inverter. Similarly, how many number of NMOS and PMOS there in the 2 by 1 multiplexer, we have done it. Okay, now I am going to this inverter. So this inverter has diagram in this fashion. This is the inverter. Here we are getting Y bar. Okay, so this is PMOS 5, NMOS 5. So for PMOS 5, inputs are Y bar and VDD. Output is Y. Okay, so Y bar, VDD. You can see for the PMOS, Y bar and VDD are the inputs. Y is the output. Now NMOS 5, I am going with NMOS 5. For NMOS 5, inputs are ground and Y bar. Inputs are ground and Y bar. Output is Y. And here you can see ground and Y bar, and output is Y. This is about last NMOS and last PMOS. Okay. So we have given definitions for all the 5 PMOSs, all the 5 NMOSs. Then supply voltage, VDD means supply voltage 1, ground means supply voltage 0. And intermediate variables, what I have written here, red color, A1, A2, A3, Y bar. These are intermediate variables which will act both as output as well as input. So we are declaring them as YS. Okay, S bar also, it is acting as intermediate output. Only S is the overall input. Okay, wherever S bar we are giving, that is complement of S, that is not the overall input we will give. We will supply only, you can see the diagram of 2x1 MUX in general, it will be like this. Only S is the input, one selection line. S bar means we will provide 0, okay? And hence I am taking S bar as wire and I am defining S bar as complement of S, okay? So wherever S bar is there in the diagram, we have done it. Now, this we will check syntax, 2x1 MUX. We will do check syntax, 2x1 MUX. No errors. Now I will go with test bench. I will go with the test bench for the 2x1 MUX. Verilog test fixture MUX 2x1 underscore TB. MUX 2x1 underscore TB. For test bench, what you have to do? You can see all the 8 combinations are required in the truth table. All the 8 combinations are required in the truth table, 000 to 111. Okay. So the same thing we will do here, 000 to 111. And yes, I will put in the beginning as per the truth table. Let me try yes in the beginning. And then this delay I will put at the output side. Delay I will put at the output side. And then 8 combinations are there in the truth table. So I will make it delay 20 nanoseconds enough. 20 nanoseconds. Copy this 7 more times. Okay, 8 combinations are there. 8 combinations are there. 368. So 000, 001, then 010, 011, then 100, then 101, then 110. Okay, then 111. All the 8 combinations I have supplied. Okay, then what I will do, before end I have to put stop. Before end I have to put stop. So now I will execute the test bench to check the 2x1 multiplexer output. So you can see here, as per the truth table, whenever S is 0, A value should come at the output. Okay, same as A value. Whenever S is 1, B value should come at the output. Okay, we will check that whether it happens in the waveform. So all these places, S value 0. So A and output should be same. You can see here, A and output are same. A and output are same. A and Y are same. A and Y are same. Okay. So all these places, S value is 1. S value is 1. So B value should come at the output. You can see B and Y values are same. BY values same. BY values and BY values are same. Okay. So this is about 2x1 multiplexer. This is about 2x1 multiplexer in the switch level modeling. But